as a response to Mr. Avinav Mishra's comment, I'm sorry if I mispronounced your name, we will create a sorting visualizer, but we cannot create this kind of project because it will take too long. So instead, what we will do is we will pick a sorting algorithm, and the sorting algorithm that I pick is insertion sort. Insertion sort is a simple sorting algorithm, and since it is simple, it is easy to implement. Okay, so that's what we will do today. So yeah, let's begin. So create a project, and then let's name that project to whatever name you want, and then create a class, and inside this let's create our J components. Okay, and if you haven't watched my video about bouncing ball, I suggest that you watch it because I tackle all of these things on that video. So yeah, in this part we will just create that, or we will just repeat the process that we did on that video. So yeah, basically what we will do is we will create our own J-frame, and then we will create also a content pane for this J-frame. So we will be the one who will create our content pane, and then we will set the J-frame's content pane to that content pane that we have just created. Okay, and now let's import this. To import this, just press Ctrl+Shift+O. Nice. So yeah, let's set the resizability of this frame to false because we do not want to mess with the width and height. Then frame dot set default close operation to J-frame exit on close. Nice. And then frame dot, let's pack the J-frame. Then frame dot set location relative to null. Then lastly, frame dot set visible to true. Nice. I'm sorry, or I apologize if I will be speaking too fast because the video will be too long if I kept on talking and talking. So yeah, now let's set the content pane to this one. So new insertion sort. Okay, insertion sort. Nice. There will be an error because our class is not a JPanel, and the set content pane requires a JPanel to be passed. So we will extend this class to JPanel. Nice. Then let's import that. Finally, let's validate our frame. Validate. Good. And there's a warning here because we have to set our serial ID, and we will just use the default serial ID. Then finally, let's create our constructor because we just called our constructor there. So let's create one. Let's set the background here to set background to color.black. Nice. And then let's set the preferred size to the dimension that we want. Okay, so set preferred size requires us to specify a dimension or to give a dimension. So we will create new dimension. Then let's pass here the width and then the height. Nice. So let's create here now, or let's define our width and height or our dimension. So let's do that. Private final int width is equal to, let's say, 1000. Then the height will be equal to width multiplied by 9 divided by 16. What this does is it creates a 16 by 9 ratio screen. So if our width is 1000, then just multiply that to 9, then divided by 16, we will get a 16 by 9 screen. So yeah, let's run the program. And there you go. Now we have a screen. Nice. So the next thing that we will do is we will draw something there. Okay. And if you haven't heard of insertion sort is a sorting algorithm. So basically, we will throw there a bunch of data, and then it will try to sort using the algorithm of insertion sort. So what is the point of sorting, or what is sorting algorithm? First, sorting algorithm is used to, of course, sort data. So let's say, for example, you want to buy something on the online shop. So let's say you go to Amazon, and then you want to sort the items based on price, or based on type, or based on the manufacturer. So you have a lot of ways to sort the items inside that online shop. So the thing that it does is it sorts those data depending on the classification that you want. So if, let's say for example, you want to sort them by price, and then you want the lowest price to be appeared first, then it will try to sort that into ascending order. So yeah, that's basically what a sorting algorithm does, and insertion sort is one of that. And unfortunately, insertion sort is not as fast as other sorting algorithm, because insertion sort runs on big O and squared, so it's quite slow. Okay, so it's really slow actually. So what insertion sort is doing is that, let's say for example we have an array of integers here, so let's say 2, 3, 1, 4, 5. Then what it does is it starts with the second index, and then it will check its left side. Then if it is lower than the value on the left side, it will swap. If not, it will move. Okay, so this will also move. Then the same question will be asked. If this value is less than the left side, it will swap. Then this will be moved. So is 1 less than 2? If yes, we will swap. Then if we reach the very first index, we will move this pointer. So just do the question again. Is 4 less than 3? If not, we will move. Is 5 less than 4? If not, then we will move. But we cannot move because there's no longer any value here. So we will stop the program. And that's basically what an insertion sort is. It will continuously check its left side as long as it is lower than its left side. Okay, and that sorting process sorts our data into ascending order. If you want the descending order, then just do the opposite. So yeah, that's what we will do now. The next thing that we will do is to override one method, and that is the public void paintComponent. Then it requires a parameter graphics G. Then in overriding paintComponent, we have to call its parent paintComponent. So that's what we will do. Nice. So here, what we will sort is not a bunch of numbers, although it is a number, but we will represent that via drawing that something, and that something will be bars, or as you have seen a while ago, we will use the bars. If you don't know what bar is, it is like the bars in the bar graph. Okay, just imagine the bar graph. So those bars will have different value for its height. Okay, so we will compare all those height. To its neighboring left side. Okay, so if the logic applies, then we will swap those values. Okay, so basically it's just an insertion sort, but instead of actual numbers, we will use bars, and then we will find the height of that bar or that specific bar, and then we will apply the logic. So that's basically what we will do. So first, let's define the size of our bar, or how many bars do we want. So let's say we want 200. We will not assume we will not do high number like 1000 or 2000, because insertion sort again is a slow algorithm, so it will take hours to be finished if we try to visualize that. So the next thing that we will define is the width of our bar. So bar width, bar width is equal to width divided by size, because we want to occupy the whole width of our J panel. Then lastly, the height. Since the bar width will be constant or will be consistent, the bar height will not. Therefore, we have to create an array for that. So bar height is equal to new int. Then the size of this array is, of course, the size. Nice. So now let's draw that. Let's draw these bars. Okay. So let's use a for loop here. Int I is equal to 0. I is less than size. Then I plus plus. There we go. Now let's draw the bars. So g.drawRec. Then it requires 4 arguments: the x, the y, the width, and the height. So the x will be I multiplied by the var width. Why did we multiply that to bar width? Because we want to respect, or we want to include the bar width of each individual bars. And let's try to remove that first so that you will understand what I am trying to tell. So the y will be 0, so it will be drawn from the top to the bottom. Then the width, of course, is the bar width. Then the bar height, index on which pointer do we are. So let's draw that. Oops, let's change the color. There's something there, but you cannot see it because of the color. So let's set the color to color that, let's say cyan, because cyan is bright. There we go. So as you can see, it only draws from 0 to 200. Of course, you cannot see the x value of 200, but that's what it does, okay? From 0 to 200. So we have to respect the width of the bar. Let's include that. And there we go, we occupy the whole width. And as you can see, it only has one height, one consistent height. Why? Because we haven't initialized our bar height yet, okay? So let's do that. Let's create a method for the bar height. Of course, we have instantiated it, so we have created an array for the bar height, but we haven't initialized its value or its actual height. So let's do that. Bar height. And then, as you have seen in the project that I have created, they are like stairs. So in each step, it has an interval that it follows. So it's like piling a bunch of blocks that will form a stair. So we have to define an interval for that, or the consistent value that we will add to those blocks to create the stairs, okay? And that value will be the height divided by size. So it's the same logic with the bar width, because we want to occupy the whole height of the J panel. Nice. So let's create another loop here for the initialization. So we will iterate through the values of our bar height or the array. So I++, and then bar height on that specific index will be equal to I times interval. There we go. Now let's run the program. And there you have it. Now we have a stair-like bars, but it did not occupy the whole height because it only gets the whole number. Why? Because this one is a floating is an integer value. So let's say, for example, the value of height divided by size is, let's say, 2.345. It will only get the 2 value because the integer only holds whole numbers. Okay, so we want to get those decimal values. So what we will do is we will transform this into float, and then we will cast this into float because what we want is the height to be float. Because if we just divide these two numbers are integer values, so it will result to an integer value. So we have to convert one of this value, or we have to cast one of this value to float, so that the resulting value will be float. Okay, and there's an error now because our bar height holds integer values, not floating values. So we will change that. Float, not float. So this will also be float. And there will be an error again because the gdrawRec requires 4 integer arguments, but what we have as the bar height is a floating value. So to fix that, we will introduce graphics 2D. So graphics 2D can draw different shapes, including, of course, floating shapes, okay, or shapes with floating values. So that we will do that. Let's cast the G to graphics 2D. There we go. And then let's use that from now on. So G2D set color to that color, and then let's define our shape. So let's use the rectangle 2D that float. So this shape requires a floating arguments. It doesn't matter if we just throw integer because it can cast that. So let's name this rectangle 2D bar because we will draw bar. So rectangle 2D that float. Then it has the same arguments, so we will just transfer this but we did not want to specify that there because we will iterate through our loop. So let's transfer that here. There we go. Then of course we have to draw that, so g2d.draw, and as you can see it requires a shape, and since our bar is a shape, that will do it. Then semicolon here. There we go. And then what is this? The method int is undefined, the type rectangle that float. We have to say bar is equal to new. We have to instantiate it. I'm sorry, I forgot. So yeah, the width, the bar width will also be float. So the same logic will apply. So we have to cast this value to float. Float, not flout. There we go. Now let's run the program. And it occupies the whole height. And it's quite annoying to see those bars. So instead of drawing, we will use the fill function. So let's do that. There we go. Better. Now we have to shuffle those values because what's the sense of sorting of an already sorted array? So let's shuffle those. Shuffle bar height. And we also want to animate that, and in animating or in using animation we can use J or timer or swing worker, but what we will use is swing worker because it is easier to work with. Okay, so it requires void. Let's just use void because we do not want to return any value, or we do not care about values, we just want to do the job. So let's name this one shuffler. There we go. Let's import that. You can use timer if you want. If you still want, it doesn't matter naman. So let's init our shuffler. Good. So we have to define that. Private void init shuffler. There we go. And then let's do that. Shuffler is equal to new swing worker. Oops, I forgot. There we go. And then we have to implement one method, and that is the doInBackground method. doInBackground. Oops, doInBackground. There we go. This one is void because again we have void here. That's the same thing. If we want integer, then just make this integer and also this one as integer. Nice. There we go. So the shuffling algorithm will be, again we will iterate through the array, and we will use two variables. So meaning we will divide the process into two. So to make the shuffling faster, so let's create the middle, because we want to divide the array into two. So yeah, let's do the looping. Int I will be from 0 to middle, then the j will be from the middle up to the end. So while I is less than middle, I plus plus, j plus plus. Nice. And then what we will do is we want to select a random, oops, this will be equal to size divided by 2. There we go. Then what we will do is we will select a random index, and then we will swap those values. Okay, so let's do that. Int random index is equal to, let's use the random class, so new random that next int. Then we will get an RNG with the scope of size, so we do not want to exceed that or any below or higher than size. Let's import the random. There we go. Then next, let's swap the value of I, or the index I, and of course the random index. Nice. And we have to define the swap. Let's define that here at the bottom, above the main method. So private void swap. Now it requires two indices. We want index, not the actual value itself, because we want to manipulate the array, not the value in that array. Okay, so we want basically what we want is an index that will point to that value, and then we will swap that ourselves, not that we will accept the value itself and then we will swap that, because if we do that, nothing will happen. Okay, so we have to get the pointer or the index that will point us to that value, not the actual value itself. Okay, as you can see here, we will get the value on that specific index, not the value of that index. I mean, I hope you understand that. I barely couldn't understand that, so I hope you get what I mean. So equal to temp. There we go. Now we have a swap method, and since this is a two-job process, so we will just repeat this, but instead of I, we will use J. There we go. And since this is an animation, we have to use thread.slip, so we will have a delay, and then let's set this to 100 of a second because it's a millisecond. Then lastly, let's repaint. There's an error because we have to either catch it or throw the exception. The exception that this method throws, or the thread.slip throws, is interrupted exception. Nice. Then let's run it. Oops, I forgot. We have to execute the swing worker. So shuffler.execute. Run it. There we go. Now it's now it shuffles. So the next thing that we will do is the actual sorting itself. So let's create another worker for that because we want it to be animated. So let's initialize that. We will initialize the sorter first before the shuffler, because we will call we will execute the sorter once we are done with shuffling, and we do not want to start the sorting if the sorter has not been initialized yet. So yeah, that's the reason why we do the init sorter first before the shuffler. So we will just copy this, not the execute, because we will execute again the sorter once we're done with the shuffling. So let's apply now the logic of the insertion sort here. So again, it requires two. The first one will be the current index, then the second will be the traversing index, or the index that will compare itself to its left side. So current index will be equal to 1 because we want the second index or the second value, and array starts with 0, so the second element will be index 1. Current index less than size, then I++, current index ++. There we go. Then the next thing is we want to initialize our traversing index. Traversing index will get the value of the current index. Then let's do the while loop. While traversing index is greater than 0. So once we have reached the 0, we will stop the looping. And of course, while the value on that index, so traversing index, is less than its left side, so bar height traversing index -1, because -1 is the left side. And for you to read the code, let's move this to the next line. There we go. It's not shuffler, it's this should be sorter. Nice. Good. Now let's do the swapping here. So what we will do is that as long as these two conditions are true, we will swap the traversing index and its left side value. So traversing index -1. That's it. Then lastly, we will apply the thread.slip. Then this one will be 1 millisecond because it's really slow. I swear it is really slow. And finally, let's repaint it. Then we will execute this once we're done with the shuffler. Okay? And there's a method in the swing worker which is the done method. Okay? So we will override that. So public void done. Then since we override it, it is best to call its parent done. Nice. And then once we're done with the shuffler, let's call the sorter.execute. Okay, this is actually the reason why we initialize the sorter first. Then let's run it. Oops, what happened? Let's see. Oh, I did not I did not traversing index. I did not decrement the value, so there's no way of this traversing index to reach the very first index. Yeah, I forgot. I apologize. There we go. Let's run it again. There we go. So the next thing that we will do is we will put a color to the current index and then to the traversing index so that we have an idea on which index are we at. So let's do that. Current index, then traversing index. There we go. Then let's just repeat this. So G2D dot set color. We will set the color red to the current index. Then let's just repeat this. Bar is equal to new rectangle. Yeah. Then this will be current index. Then this will be current index. And if you cannot see that, let's just put that here, the bottom. There we go. Then lastly, let's fill our G2D. Fill with our bar. Then let's just repeat this for the traversing index. Traversing. This will be traversing index. There we go. Then this will be colored green. Run it. Oops. I forgot. Oops. We have to destroy this. We have to remove this. So that the current and the traversing index will use the global variable instead of local variable. There we go. Yes. We now have an insertion sort. Yay. And it throws an error. Why? Because once we are finished with this loop, the value of the current index will be 200. And again, the last value or the last index in our array is 199, not 200. So it will go out of bounds. So to fix that, let's just say the value of our current index to 0 and the traversing index. There we go. And then let's change the size of this array so that you will understand how slow insertion sort is. So let's set this to 500. Run it. And yeah, let's just watch this sorting algorithm to be finished. So yeah, thank you for watching, and I hope you understand what I just did. If you have any more questions, just leave a comment and then I will try to answer that, and I will try to clarify any queries that you will throw. So yeah, if you want to change any algorithm, let's say you want selection sort to be visualized, just change the logic inside the sorter worker. Okay? And let's say you want merge sort, just change the logic inside that, and that's basically it. That's how easy it is to visualize any sorting algorithm. So yeah, enjoy the video, and I mean just wait for the insertion sort to be finished. Bye bye, see you in the next video.